Hello guys, welcome to Edexcel IAS for you. Today we're going to discuss section C of 2025 June Unit 2 Chemistry paper. Alright, so let's move on to the questions. Question number 17. Magnesium carbonate has been studied recently as a potential material for the removal of carbon dioxide from the atmosphere. The value of N in a sample of hydrogen magnesium carbonate is MgCO3 NH2O can be determined by the reaction of hydrochloric acid. The equation for the reaction is shown. So they have given the equation and the procedure as well. So in step 1, add 0.06 moles of hydrochloric acid and excess to a 2.35 gram sample of hydrogen magnesium carbonate. Step 2, when the reaction is complete, transfer the resulting solution to a 250 cubic centimeter volumetric flask. Make up to the mark with deionized water and mix thoroughly. In step 3, titrate 25 cubic centimeter portions of solution with sodium hydroxide solution of concentration 0.096 moles per cubic decimeter. So the mean titrate volume is 27.15 cubic centimeter. Determine the value of N in the hydrated soil. So first of all, we should know what is reacting with sodium hydroxide. Sodium hydroxide reacts with excess HCl, right? Sodium hydroxide reacts with excess HCl. So by calculating the moles of HCl using titration, we can find out how many moles were in excess. So by subtracting that value from the initial number of moles of HCl, we can find out how many HCl that were reacted in the reaction, right? So here we should work out to find out the number of moles of HCl, excess HCl. To that, we should find out the moles of NaOH in the titer. To that, we multiply the titer volume by 0.096, which is the concentration, and we should divide it by 1000 since it is given as cubic centimeter, right? So we'll get 0.026, but to get the excess HCl we should multiply it by 10 because they have taken 25 cubic centimeter portions from the 250 cubic centimeter sample in volumetric flask, right? So we should multiply it by 10 to find out the excess moles of excess HCl. So to find out reacted HCl moles, we should subtract the initial number of moles of HCl by the excess HCl, right? So we will get 3.39 10 to the minus 2 moles, right? So using that, we can find out how many moles of magnesium carbonate were reacted in the reaction, right? So we should use stoichiometry. Stoichiometry is 1 to 2. So we should divide the moles of HCl by 2 to find out the moles of magnesium carbonate. So we will get 1.695 10 to the minus 2 moles. So we should substitute that value to the equation N equals M over Mr, which is moles equal mass over molar mass, right? So we should find out this N. So after we substitute the value, we can subject this N. So you will get N equals 3. Alright. So let's move on to part B. The enthalpy change for the thermal decomposition of anhydrous magnesium carbonate delta RH was measured indirectly using the enthalpy changes for two reactions shown and applying Hess's law. Reaction 1. In reaction 1, magnesium oxide reacts with HCl, and in reaction 2, magnesium carbonate reacts with HCl. So they have given the enthalpy change of the reaction 2, but we should find out the enthalpy change of reaction 1. So in an experiment was carried out to measure the enthalpy change of reaction delta RH1 for reaction 1. So 1.92 grams of magnesium oxide 1.92 grams of magnesium oxide was added with stirring to 40 cubic centimeter dilute hydrochloric acid, which is in excess, in an insulated container. The temperature rise was 30.8 degrees Celsius. Calculate delta RH1 for reaction 1, include sign and units in your answer, right? So first of all, we should find out the energy. To that, we should use Q equals mc theta equation. So the mass is 40, which is the mass of the solution, and specific heat capacity is 4.18, and temperature rise was 30.8 degrees Celsius. So you can find out the energy, which is 5.15 10 to the power 3 joules, or 5.15 kilojoules. Then since magnesium oxide was the limiting agent, we should find out its number of moles. So it should be divided, mass of magnesium oxide should be divided from the number of its MR value. So you'll get 0.0476 moles. Then divide the energy from the number of moles, so you will get 108.1 kilojoules per mole. But remember, this is the temperature was rising in this reaction, so it is an exothermic reaction. So you should include a negative sign. Roman number 2, the enthalpy change of decomposition of delta RH of magnesium carbonate can be found using Hess cycle. Calculate the enthalpy change of decomposition by using completed Hess cycle. Use your answer to B1 and the enthalpy change of reaction for reaction 2. Give your answers to an appropriate number of significant figures. So first of all, we should complete the Hess cycle here. So we know we have calculated the value of reaction 1 and they have given the reaction enthalpy change of reaction 2. So this is the cycle. Then enthalpy change of the second reaction is equal to sum of enthalpy change of reaction 3 and 1. So now we can substitute the value and subject x. So you will get the delta RH value of decomposition of magnesium carbonate, which is 111.68 kilojoules per mole. Roman number 3, give a reason why it is not possible to measure the enthalpy change for the decomposition directly. So what is the reason for that? The reason is we cannot measure the temperature change of a solid accurately, right? So the answer is it is difficult to measure the temperature of a solid. Part C, the steps involved in using magnesium carbonate or in a process to capture carbon dioxide from the air are shown. They given here mechanism. So point 1, the magnesium carbonate is heated in a furnace and decomposed, and the carbon dioxide produced is stored. The magnesium oxide produced is transported to plots of lands where it is spread to a depth of 0.1 meter and reacts with carbon dioxide over a year. The magnesium carbonate formed is then returned to the furnace and the process repeated. Heat in the furnace decomposes the magnesium carbonate accounts for most of the energy requirements of the process. So in Roman number 1, explain with reference to the thermal stability of group 2 carbonates. Why use of calcium carbonate rather than magnesium carbonate would increase the cost of the process. So generally we know the thermal stability of carbonates increases down the group. So why is that? The size of the cation increases down the group, right? So calcium Ca2 plus ion is larger than the Mg2 plus ion, right? So the polarizing power decreases. So once the polarizing power decreases, it polarizes CO bond. It polarizes CO bond less, right? So magnesium ion having more polarizing power than calcium ion. So magnesium ion polarizes CO bond higher than calcium ion does, right? So CO bond of calcium carbonate is less weakened, so it need higher energy to break these bond and to decompose the compound, right? So the answer is calcium ion is larger than magnesium ion, so magnesium ion is more polarizing than calcium. So CO bond is less weakened in calcium carbonate, therefore it need higher temperature to decompose. So final question, Roman number 2. Methanol can be produced from the captured carbon dioxide by reaction with hydrogen using copper catalyst. The equation for the reaction is shown. So they have given the delta H value of the forward reaction, and they are asking explain why the conditions for the industrial production of methanol are a pressure of 50 atmospheres and a temperature of 250 degrees Celsius, right? So they have given here the delta H value of the forward reaction. So it is minus value, so it is an exothermic reaction. The forward reaction is an exothermic reaction. So once the temperature increases, yield of exothermic reaction decreases, right? So higher temperature will decrease the yield of methanol. Higher temperature will decrease the yield of methanol, which is in the forward reaction, right? But further to increase the yield of the reaction, what will happen? We decrease the temperature of this reaction mixture further. The further reduction of temperature will decrease the rate of the overall reaction, right? So again, the methanol yield will decrease. So this 250 degrees Celsius temperature is the ideal temperature for this reaction, right? So then we should work out to find out the effect of the pressure, right? So there are 4 gas molecules in left hand side of this reaction and 2 gas molecules, which is less number of gas molecules, in right hand side of reaction, right? So once the pressure increases, the yield of forward reaction will increase, right? The yield of forward reaction will increase. So the answer is, since the forward reaction is exothermic, higher temperature decreases the yield of methanol, but lower temperature decreases the rate of reaction. Since there are more gas molecules in left hand side, higher pressure increases the yield of methanol. So guys, today we're gonna wind up our lesson. So we have done our Unit 2 2025 June chemistry paper. So I'll upload more chemistry paper discussion and videos as well. So till then, have a good time. Thank you for joining me.